Hello everyone, welcome back to my channel Notebook Maths. Today I am going to solve here one important problem, very important, repeated in many exams. That is from application of derivatives chapter 10 INTER-1B Maths, exercise 10B, third bit, sixth question. Okay, what is that question? Here I have written that question. See here, if the tangent at any point on the curve x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3 intersects the coordinates axis in A and P, then show that length AB is a constant. Okay, so today I am going to solve this important, very important question, children. So watch complete video. Solution here I am going to solve. So here first I am going to make a figure. If the tangent at any point on the curve, means let us take x-axis and y-axis here. Okay, x-axis, this one is y-axis. Okay, O is the origin, and what are the axes in A and B are given? Coordinates are A and B. Let us draw a tangent line, that is A and B coordinates. Okay, and what is the point? Show that the length AB is a constant. We have to show that the length of AB tangent at any point is x1 comma y1 is constant. So we have to prove. So let us take this as a figure. So please make figure before going to start your solution, so that you can easily understand the problem what to show. Let us write now equation of the given curve. Equation given. Equation of the curve is, what is given? X power 2 by 3 plus y power 2 by 3. By using this, we have to show that AB is constant. Okay, length of AB is a constant. Okay, now differentiate with respect to x here. With respect to x, we have to differentiate. Okay, first part we have to differentiate. Here x power 2 by 3, that is formula we have x power n is equal to n into x power n minus 1 is the formula. Very important formula. So 2 by 3 is n value, x power 2 by 3 minus 1. 2 by 3 minus 1 is minus 1 by 3. Plus again 2 by 3. We have to differentiate this term, y power minus 1 by 3 equal to, this one is constant. Okay, y again dy by dx. Okay, this becomes constant. So differentiating we get 0. Now what we have, simplify this equation. 2 by 3 x power minus 1 by 3 plus 2 by 3 y power minus 1 by 3 into dy by dx. So this term get to this side, it becomes what? Minus. So this is dy by dx. I am writing this x term to this side. This becomes minus 2 by 3 x power minus 1 by 3. Please watch complete video. In easy step I am going to solve this problem. So now dy by dx equal to, find out dy by dx from this above. Okay, minus 2 by 3 minus x power 1 by 3. This 2 by 3, this 2 by 3 get cancelled. Okay, this y comes to denominator, y power minus 1 by 3. Okay, this y comes to numerator, becomes 1 by 3. This power becomes negative, becomes positive, and x power 1 by 3 minus, no, this one x power minus 1 by 3, sorry, this comes to denominator, it becomes plus 1 by 3. Okay, understood? Now what here, dy by dx is what? Minus is already there, so keep minus as it is. So dy by dx equal to minus y power 1 by 3 by x power 1 by 3. Okay, now dy by dx equal to how much? Minus 1 by 3 by x power 1 by 3 we get. Okay, here. So this is keep as 1, equation 1. So now equation of tangent line. So we have the tangent at any point, question we have on the curve is given, no? So we have to take equation of the tangent At what point we have taken? P x1 comma y1. What is the tangent formula? That is y minus y1 equal to dy by dx into x minus x1 is the formula. So substitute dy by dx in this formula. So what you will get? Y minus y1 so y minus y1 is equal to dy by dx is what, children? Minus y power 1 by 3 by dx is x power 1 by 3 into x minus x1. Now simplify this whole equation, we get constant value. Now what is here? Denominator, we have to multiply this term and this term to numerator. So x power 1 by 3 into what is that? Y. Okay, x1 and y1 we have to take, because here point is x1 y1, no? So you have to take y1 x1. Okay, this is already y1 minus y1 x minus x1. Now multiply x1 x1 power 1 by 3 into y minus y1 into x1 1 by 3 is equal to, multiply this term, minus x into y1 1 by 3 plus minus into minus plus x1 into y power 1 by 3, y1 power 1 by 3. Now what we have here? X1 is there and y is there and x is there. So take this x to this side, it becomes positive, y1 power 3 and this term is y. Okay, so this term is y and this term is x. Okay, and all powers which are 1 by 3 1 by 3 and this is 1 by 3, this is 1 by 3. Okay, now x power y1 1 by 3 comes to this side and y into x1 power 1 by 3. Okay, now this one gets to this side, it's become what? Positive. And here is x1 is there, write down x1 y1 power 1 by 3 and this one is positive y1 x power 1 by 3. Okay, now what? Here we have minus minus. Okay, now what we have? x1 y1 power 1 by 3 plus y1 x power 1 by 3. So I am taking common x1 power 1 by 3 y1 power 1 by 3. I am writing inside this x1, this is x1, I am written power 1 by 3, but we have power 1 here, y1 also 1. To make it 1, what we have to add inside? x1 power 2 by 3. Okay, y1 power 1 by 3 I am written and here y1 power 1 is there. To become y1 power 1 we have to write y1 power 2 by 3. Okay, to make it as x1 power 2 by 3 y1 power 2 by 3, because we have written in the question given that a power 2 by 3. To use this we have to write this one. Take x1 power 1 by 3 as common, so y1 power 1 by 3, so this becomes 1 again. 1 by 3 plus 2 by 3, 3 by 3 is 1, plus y1 power 2 by 3 y1 power 1 by 3 x1 power 1 by 3, on multiplying we get 2 by 3 plus 1 by 3, 3 by 3, again we get 1. Okay, now I am writing this whole term this side, x y power 1 by 3 y into x1 1 by 3. So what we have obtained here? X power 1 by 3 into y1 common we have taken here 1 by 3, inside we have x power 2 by 3 y power 2 by 3, that is x1 y1. So given we have, what is given in the question? Since we have x power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3. Okay, now substitute this a power 2 by 3 in place of this. X power 1 by 3 into y power 1 by 3 x1 y1 into a power 2 by 3. So now x1 x1 xy1 1 by 3 minus y x1 1 by 3 is there. So very easy. Now we have to take LCM. Okay, take this to this side. So what becomes xy1 power 1 by 3 by this one? What we have to do? Take as this comes to this side, not LCM, this come to this side, becomes separated terms we have to write. Okay, now x1 1 by 3 y1 1 by 3 into a power 2 by 3 is equal to what remaining in this side? 1. Okay, now what is this? 1 we got here. Now here what this one is, y1 1 by 3, y1 1 by 3 get cancelled. Here also x1 by 3, x1 1 by 3 get cancelled. Remaining terms are x by x1 1 by 3 into a power 2 by 3 minus y by y1 1 by 3 into a power 2 by 3 is equal to 1. Now what we have here from figure, OA is equal to x1 1 by 3 and OB is equal to y1 and this one is a 2 by 3. y1 1 by 3 into a 2 by 3. Okay, I am taking as these terms are OA and OB. So take this as, we know the perpendicular formula, that is AB square equal to OA square plus from the figure OB square. That is what? AB square equal to OA square OB square. OA square plus OB square to get AB. So that we have to use. Okay, we have to use this. So AB square is equal to OA square is equal to how much we have? OA is x1 2 by 3 into OA is x1 1 by 3 into a 2 by 3. A 2 by 3. OB we have taken this term minus 1 by 3 into a 2 by 3. So now we have to square these two terms. OA square, OA means x1 1 by 3 is 2 by 3 into a power 4 by 3 plus OB means minus get positive y1 2 by 3 into a 4 by 3. Okay, now these terms are x1 2 by 3, I am writing again clearly here, y1 2 by 3 into a 4 by 3. Take out this a power 4 by 3 as common, x1 2 by 3 plus y1 2 by 3 remaining terms inside. So after taking a power 4 by 3 common, we get these two terms as we have already given in the question, that is a x power 2 by 3 plus y power 2 by 3. By using this we get a power 2 by 3. So as it is, we have to again substitute this as a power 4 by 3 into a power 2 by 3. So here a power 4 by 3 into a power 2 by 3 is there. So as bases are same, power should be added. 4 by 3 plus 2 by 3, that is a power 3, denominator 5 plus 2, 4 plus 2 is 6, 3 ones are 3 twos are, that is a square we get. So AB square is equal to a square. This is AB square value we have obtained. So AB square is a square. Now this implies AB is equal to how much, children? A. So this is constant. So what we have proved here, AB is constant, hence proved, children. That's all, very easy to do. First we have to differentiate and equation of the tangent line we have to use, and separating term we have to simplify, and denominator we have to take it as this term to this side, separate terms, we get 1 here, and apply this Pythagoras theorem formula, AB square equal to OA square plus OB square. Okay, now we get, after simplification taking out common, we get this as a constant. This is very important problem, so that I have explained in one video, single problem I have explained in this video, so that you can understand easily each and every step perfectly. So watch complete video so that you can understand this problem. Very easy to do. Okay, repeated multiple times, children. 6th problem from 10th chapter, exercise 10b. This is okay. By using this we have proved that, showed that length of AB is a constant. Okay, thank you for watching. Like, share and subscribe my channel for more updates on maths topics. Please keep watching my channel. Thank you.